you're asked to use the second derivative test to find the x values of all relative extrema, that's spelled wrong, of the function f of x equals 2 sine x plus root 2x on the interval 0 to 2 pi. Now, how do we do that? Well, the second derivative test has two parts. The first one is find where the first derivative equals 0, because that is going to tell us where those extrema might be. So one is find those critical points using f prime. And so when we do that, f prime of x is, well, 2 sine x, the derivative of 2 sine is going to be 2 cosine, plus root 2x. Now, this looks a little scary, but what you might notice is that this root 2 is just a constant next to the x. When we find the derivative of something with a constant, or something with just a variable of x, it's just the constant, so plus root 2 is our derivative. Now we need to set this equal to 0 to find our critical points. I'm going to subtract root 2 on both sides, divide by 2, so I'm going to get negative root 2 over 2 equals cosine of x. Now, sooner or later you should have this unit circle memorized, but I have this here just in case. We know that cosine is always the x values on our unit circle, so we need to know where is the x values negative root 2 over 2. And that happens in two locations between 0 and 2 pi. It happens at 3 pi over 4 and 5 pi over 4 on our unit circle. And so that tells me that x equals 3 pi over 4 or x equals 5 pi over 4. Now, what do we do with those? We now have to plug them into the second derivative to see if it's positive or negative to determine if there's a maximum or minimum. I'll use blue for this to plug in to f double prime to find max or min. And that is determined by the sign of the second derivative. So let's try it. We're going to do f double prime. Let's find out what it is first. The second derivative of f, 2 cosine x, derivative would be negative 2 sine x. And then the derivative of root 2 is just 0, because that's a constant. So now we need to find f double prime of 3 pi over 4, which is negative 2 sine of 3 pi over 4. Again, we can look back at our unit circle. I would like for us to know this at some point. Sine of 3 pi over 4, I see, is root 2 over 2. So that'll equal negative 2 times root 2 over 2. And this will equal negative root 2. It doesn't really matter what it equals, but what we notice is that it's less than 0. What does that tell us? This tells us that we have, and I'll write this in a different color just because it's our answer. When we have less than 0 for the second derivative, it means we have something that's concave down, like that. And so that means we have a maximum. So we can say we have a relative maximum at x equals 3 pi over 4. Because, two reasons. Because f prime of 3 pi over 4 is 0, and that we showed here. And f double prime of 3 pi over 4 is less than 0. Now, what about at our other point? Let's figure out what's going on there. F double prime of 5 pi over 4 equals negative 2 sine of 5 pi over 4. Again, we're going to look at the y value. So here that's negative. So negative 2 times negative root 2 over 2. This is going to give us positive root 2, but again, it doesn't really matter. What we need to notice is that it's negative times negative, which will give us a positive value. And so what does that tell us? Since we have a positive, it means our function's concave up at that critical point. Since it's concave up, that means we're looking at a minimum. So we get a relative min at x equals 5 pi over 4, because f prime of 5 pi over 4 is what? It's 0. We showed that over here. And f double prime of 5 pi over 4 is greater than 0. And there we have it. That's your justification, as well as the use of the second derivative test to find the relative, let me correct this, extrema of our function.